All right, guys, so let's start looking at some examples of, we're going to start solving quadratics by factoring. Okay, so we have this, this equation. I'm going to actually go ahead and do this. And we are going to try to want to solve this. Now, let's go through the steps. Our first step is going to factor completely. Okay, so what type of a problem do we have going on here? Okay, well, we have 3 terms. So 1, 2, and 3. How do we factor when we have 3 terms? Okay, we're going to use that x method and we're going to factor it down. Okay, so I'm going to set up the x method really quickly. Most of you guys should actually do this pretty fast since you had a lot of practice with it. So I have my x. What's going to go in the top is my a and c. My a is 1 and my c is 9. So 1 times 9. Okay, 1 times 9 is 9. In the bottom is my b, that is 6. Okay, what goes in the denominators is our a, in this case it's going to be 1. Okay, we're looking for factors of 9 that whenever you multiply them give you 9, and that when you add them they give you a positive 6. So let's think of some factors. Well, I can think of 2. What is 3 times 3, right? Okay, so that is our factor. So we have 3 times 3 equals 9. 3 plus 3 equals 6, okay? Remember, whenever we have the big X, we have a coefficient of 1 here, so we can reduce, but we don't need to because it's already reduced for us. So now we can go ahead and write our factors. So we have our double sets of parentheses. Okay, what goes first, numerator or denominator? All right, it's the denominator. So 1x plus 3 and 1x plus 3. So what's going on here? Okay, well, I have 2 identical pieces. So I'm going to leave it that way. That's okay. All right, now we have pieces. This is where that part of our steps is to set each piece equal to 0. Okay, when I say a piece, it's separated by multiplication. So let's see, where is multiplication going? So it starts here and ends where? Right here, right? So that's one piece. So we're going to set this piece equal to 0. Also known as a factor. We're setting our factors equal to 0. Okay? We'll start here, and where does that end? Right here. So that's another factor. So x plus 3 equals 0. Okay. Now we solve. Okay, we're trying to find our x-intercepts. We set each piece equal to 0. Let's solve for x. We would subtract 3, and x equals negative 3. Subtract 3, and x equals negative 3. And you're probably going, time out, I'm getting the same answer. And that's totally fine. So what would be your x-intercept? Do we need both? No, we only need one of them. So this is actually a 1 solution, and our graph later on you're going to see is going to actually bounce off of x equals negative 3. Okay? What's another way that we could have taken this example and have, how could we have wrote it a little bit differently? Like, can we do something up here? What's another way that you may have seen this type of a problem? Well, if they're exactly the same, can't we put them together with an exponent of 2? Sure. Okay, so if you had something like this, just in case if you see it, you would know how to deal with it, okay? All right, how do you think you can get rid of the power of 2? Okay, you're going to actually be learning this in the next couple of days, but we're just going to briefly go through it. What would be the opposite of squaring something? What's your thoughts there? Okay, how about the word square rooting something? Okay, so that's actually opposite. Squaring something and square rooting something are opposites. So to get rid of the square, we would square root it. So goodbye square. Whatever we do to one side, you have to do the other. Okay, 0 squared is just 0, and we're left with x plus 3 equals 0. Doesn't that look kind of familiar, right? Okay, subtract 3 again from both sides, and you end up with x equals negative 3. Okay? Do you still get the same answer? Sure. Could you have done what we did up here? Yeah. Okay. But the key part is factoring completely. That's what we did right here. And then setting each factor equal to 0, or setting each piece equal to 0. Does that make sense? Okay. All right, let's try some other ones that are a little bit harder, okay? All right, so let's take a look at another example. What if we take a look at these? Okay, number one here, I know we had a number one before, but it's okay. Let's take a look. We have r squared minus 2r minus 24 equals 0. Okay, couple key things that I did want to tell you. Factoring completely is definitely the first step, but the overarching thing that you should have learned when we were factoring is everything should be on one side. Okay, all of your equations must be equal to 0 or to y or f of x, okay? I'm just getting you in the habit. I didn't put that in our steps because you should have known that. So if you need to write it down, go ahead. I'm going to up here. Just saying make sure equations are equal to 0 or y or f of x, okay? If there's stuff on the other side like DC down here, this is going to be bad news for us, and I'll tell you how you fix that, okay? But let's start off with this one. Okay, everything's on one side. It's equal to 0. We're good to go. Step 1, factor completely. What type of factoring will we be doing here? What type of factoring will we be doing here? Okay, there's 3 terms. You got it. Okay, so we are going to what? The x method. Okay, so let's set that up real quick. Okay. Always check for a GCF. Do you see one in this one? No, I don't have any numbers that are in common, so we're okay. What goes in the top is our A and our C. Our A is 1, okay, and our C is negative 24. 1 times negative 24 is negative 24. What goes into the bottom? B, right, which is negative 2. You got it. What goes in our denominator? 1, or A. Okay, we're looking for factors. So what are some factors of negative 24 that when you add them up get you to negative 2? So think about that for a minute. Okay, I came up with some. What are some other ways that you could have used your calculator to help you? If you need to, I can think of these at the top of my head. I know that negative 24 can break down into 6 and 4. Now the question that I always have this think in my head is, well, which one's going to be negative, right? But the calculator shows you that already. Okay, so of course, if you need to use that, I'm going to put the negative 6. Right, because negative 6 plus 4 gives me negative 2. And then negative 6 times 4 gives me negative 24. So I found my factors. So those go on the top. We good? All right. Don't need to reduce. No issues here with that. Now let's go ahead and factor completely. Let's write it out. So denominator goes first. So we have r minus 6 and then r plus 4 equals 0. Step 1 is now done. Step 2 says to set each piece equal to 0, or set each factor equal to 0. So how many factors do we have going on here? Right, you got 2. So I'm going to take r minus 6 equals 0, and then I'm going to take r plus 4 equals 0. Okay? Because we're finding the x-intercepts, or the r-intercepts, I guess, in this case. We're going to add 6 to both sides. We get r to equal 6. Minus 4 from both sides. R equals negative 4. Okay? So how many x-intercepts do we have going on now, or r-intercepts? That's right, we have 2 different answers, so we have 2 intercepts. Okay, and you're done. All right? A couple ways that you may see this written as an answer. Sometimes they're in the braces saying that it's a set of numbers. So you may see it like that. You may see it like this. Okay? All right. Easy enough? I hope so. Okay. Let's take a look at example number 2. Okay. What do you see? Alarm should be going off. This thing up here, you should be going, hold on, you said everything has to be equal to 0. Is that in this case? No. How could we make this so that something's equal to 0? What maybe do we need to move out of the way? Yeah, well, let's get rid of this negative 4. How would I cancel it out and move it to the other side? Well, I would add it. Okay, This cancels out to 0 equals negative 13 plus 4. We get a negative 9. And we end up with this. Okay? You learned last week with factoring. Now we have everything equal to 0. What does this look like? We have some type of squared. I could take the square root of 4. I could take the square root of 9. So those are squares. And then I have this subtraction sign, also known as a difference. So what is that? Oh, difference of squares, right? Okay, so we're going to factor completely. That's step 1. Okay, difference of squares. Take the square root of 4, which is 2. So we're going to plug 2 into both. Okay, square root of x is x and x. Okay, square root of 9 is going to be 3 and 3. Okay, and then what do we got to do with our signs? Well, we got to change it up. One's going to be positive, one's going to be negative, right? Because when you take a square root of something there. Okay, still keep it equal to 0. You're done with step 1. Easy, right? Okay, step 2, set each piece equal to 0, or each factor equal to 0. So I'm going to take this one, set it equal to 0, and I'm going to take this one and set it equal to 0. Okay? What do we do first here? Subtract 3. Okay? Divide by 2. Leave it as a fraction for right now. That's totally fine. Okay, so we get negative 3 over 2. Let's go over here. Add 3 now. So we're left with 2x equals 3. Divide by 2. And you get 3 divided by 2. So how many x-intercepts or how many solutions do we have in this problem? And you got it again. We have 2. Oh, excuse me. Okay, does that seem pretty easy? All right, let's take a look at 2 more examples, and then we're going to try some try problems.